A function is said to exhibit dynamic polymorphism when it exists in more than one form. That is, the same function exhibits different forms at different times based on some situation in the programming paradigm, based on some result of the programming paradigm. The compiler associates a function with a class by identifying the type of object or pointer. We have seen using pointers how to call functions. So, it associates one function with a class based on the type of object or the pointer that calls the function. Invoking the function means calling the function. And the process of associating a function with an object is only called binding. So, this term binding is highly important when we are executing a program, because the compiler needs to know which object is calling which function. Only then it can return the result of the function to that object. In the previous program we saw O3, the result of that added value has to come back to O3. For that reason, the compiler should know that that statement only called that particular function. Otherwise, where will that result go? We will not be able to see the result. So, that binding concept is the main thing in execution of the program. The compiler should associate the function with the object, and that process is called binding. Binding of a function to a class at execution time, runtime is nothing but execution time, that is called late binding. Normally during compilation itself, the compiler will understand that this function is called by this class or this function is associated with this object. Normally while it is compiling the program itself, it should identify. That is the normal static binding. But if it is going to bind only during the execution of the program, that is called late binding or dynamic binding. Like you have dynamic memory allocation, like that dynamic binding. And dynamic polymorphism is normally implemented using virtual functions. Virtual function is a concept which we will have to study after we study about inheritance. So, we will see an example why virtual functions are required to implement this dynamic polymorphism. Say you have an employee class. This is called the base class. It is having a function called calculate. Base class is the class from which other classes inherit. We have already seen the definition of inheritance. Say you are having another class called trainee and a class called manager. Both these classes are inheriting from the employee class. That means they are called derived classes or subclasses. Both are having the same function, calculate again. So, when they inherit itself, they inherit the calculate function. In addition to that, they are having their own definition of this calculate function. So, in this case only we have to identify the concept of dynamic polymorphism. The same function calculate is exhibiting different forms in different classes, though the classes are related to each other by inheritance. So, this is just a skeletal picture of the program. Class EMP with a calculate function, you are closing the class. Class trainee, public EMP is nothing but the syntax for inheriting. This is having the same function calculate with its own definition. Then you have class manager, again inheriting from EMP with the same function calculate. So, how does a compiler know when you create an object with which class it should call the calculate function? So, that is where dynamic polymorphism comes into picture. You are having the main function, you are having the creation of a simple object and a pointer object. This pointer is called the base pointer because this is the pointer for the base class or the super class. So, that is called the base pointer. E1.calculate, the normal way of calling the calculate function. So, this will call the calculate of the main class. We have to use the new operator with the pointer. So, you are creating an object for the trainee class, you are calling the calculate function, creating an object for the manager class and calling the calculate function. So, what you will understand from this? You will be of the opinion that because you are creating the pointer for the trainee class, this calculate will go to the trainee calculate, and here because you are creating the object for the manager class, this will go to the manager calculate, but that is not the case. In the case of inheritance, because both of them are subclasses for this employee class, the compiler will not take them as different classes. There is a big relationship involved in that. So, simply by using base pointers, you cannot implement dynamic polymorphism. That is why you need virtual functions. So, before you understand dynamic polymorphism, you have to know about inheritance, and then we introduce the concept of virtual functions.